Good morning, dear students. My name is Ferhan Mazher, and the subject today we are studying is Cambridge O Levels Physics 5054. Today we have set our hearts to solve uh, paper 4. We call it ATP, and this is called Alternative to Practical. And today we have selected October-November 2022 4-2 paper. This paper 4, this ATP paper belongs from the Zone 2 or the Variant 2. So the time allowed for this paper is 1 hour. So let's start today's paper. So here we go. So October, November 2022 and 4-2 paper. The first question is coming up on your screen. It says that a student measures the resistance R of a lamp for different values of the potential difference V across it. The student connects the circuit shown in the figure 1.1. So here we have a meter rule, and on this we have a wire, and here we have the crocodile clips, and at this point of the wire we have connected our wire. Here we have a lamp, here we have a power supply, this is the switch. This is ammeter, this is voltmeter. Here we have a lamp. So this voltmeter is basically telling you how much voltage is being used by the lamp. And wherever you will put this paper clip on this wire, this much length of the wire will be used. So he says the student closes the switch, connects the crocodile clip at a length of 10 centimeter of the resistance wire, records the potential difference V across the lamp, records the current I in the lamp, opens the switch. Figure 1.2 shows the reading on the voltmeter and the ammeter. Okay, so let's have a look at this reading. Okay, so you look at this first of all, the voltmeter. This is 0, this is 0.5. So this will be 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, and 1. So how much is this? This is 0.2 volt. And if you look at this reading, ammeter reading, this is 0.5. So this is 0.1, 0.2, 0.3, 0.4, 0.5. So this reading is basically 0.09. This reading is 0.09. Okay. So this is what they have shown us. He says record in the table 1.1 A part the values of the V and I. So the value of the voltage, the value of the voltage is, how much was that value? 0.2. This was, the value was 0.2, and this value is 0.09. Okay. Then they say, okay, the student repeats the procedure with different lengths L of the resistance wire. The student's results are shown in the table. So here we have the length, the potential difference across the lamp, the current through the circuit, and the resistance here. The students, the B first part is, he says, complete the top row of the table 1.1 by calculating the resistance R of the lamp when the L is 10 centimeter. Use the equation R is equals to V by I. So I know the value of the voltage, I know the value of the current. So the R will be equals to, very simple, R will be equals to 0.2 divided by 0.9. So I have 0.2, 0.09, and here we have the calculation. So the R will be equals to 0.2 divided by 0.09. When you divide this, you get 2.2 ohm. 2.2 ohm. 2.2 ohm is the right answer. 0.2, 0.09, 2.2 ohm is the right answer. So in the table, I will write 0. What is the answer? 0.2. We got 2.2 ohms. Sorry. 2.2 ohm is the answer. So your table will be 2.2 ohm. Okay. So then their question is, the student forgets to write in the current value for L equals to 100 centimeter, calculate the current and write its value in the table. 1.1. Okay. So for 100, I know the voltage, I know the resistance. So the I is question. You know, I will be equals to, the I will be equals to V divided by R. So I know the resist voltage. For 100 centimeter, the voltage drop is 2.5 and the resistance is 11.9. Just put these values here and you will get the answer. So R is equals to V by I is equals to V by R. I will be equals to 2.5 divided by 11.9, and that will be 0.21 ampere. 0.21 ampere. So our answer is right. 0.21 is the right answer, sir. 0.21 is the right answer. Okay, so this is the answer. So I will write here 0.21. So this will be 0.21. This is the table. Okay. Then their question is, the student examines table 1.1 and states that the resistance R of the lamp is directly proportional to the length L. State if you agree with this statement. If two quantities are directly proportional to each other, their ratio remains constant. So R divided by the L value should remain constant. Okay. So from the table, I can choose R by L. For example, I can choose this and this, divide them, check what is the ratio. Then you can take this value and take this value and divide them, check what is the ratio. If the ratio is same, then they are directly proportional. If their ratio is not same, then they are not directly proportional to each other. So our answer is no, I don't agree. Justification is R1 by L1 is equals to 2.2 divided by 10, that is 0.22. And when you do R2 by L2, that is 5.4 divided by 30, that is 0.18. You see the ratio is not same. Here it is 0.22, here it is 0.18. Ratio of the R to L is not constant, so the resistance is not directly proportional to the length. This is our answer. You see the ratio not constant. Our answer is right. Okay, so I hope you understand this question. Okay, we are going to the D part. He says, on the grid provided in the figure, 1.3, plot a graph of R on the y-axis and V on the x-axis. Start both the axes from the region. So the R will be here and the V will be here. So the V will be here. Okay. So then we can plot this graph very easily. And R and V. This is on the x-axis. The R is on the y-axis. Okay. So this is my table. So I'm going to plot it. Let me show you. So at 0.2, the resistance is 2.2. So first of all, I have labeled it. You can see the label. Here is the labeling. 0.5, 1, 1.5, 2, 2.5. And this is 0, 2, 4, 6, 8, 10, 12. And at 0.2, this is 0.2. The value is 2.2, which is here, this point. Okay. Then we have 0.7 and the R will be 5.4. 0.7, 5.4. 0.7 is this. And 0.7 will be this one. 5.4. This is the dot. And then you have 1.2, 8.6. 1.2 will be this, and 8.6, it will be here. Okay. Then you have, you will put the dots of 1.7, 10.6, 2.2, 11.6, 2.5, 11.9. So you can plot these points. Let me show you by reducing the size a little bit. Yeah. So we have plotted all these points. Okay. Then we have to draw a smooth curve. The curve of the best fit. Okay. So one point is left up and one point is left below the curve. It's a smooth curve. I have tried to draw the smooth curve. Okay. So you can see this. Okay. Now what they want us to Using your graph, describe how the resistance R of the lamp changes as the potential difference V across it changes. Because you see, this is not a straight line. It's passing through the origin, but it's not a straight line. And as the V is increasing, the value of the R is increasing. Yes, the V, when you increase the V, the R value is increasing, but they are not directly proportional to each other because this is not a straight line. So the rate of increase of the R is gradually decreasing. Okay, so my answer will be, as the voltage increases, resistance increases non-linearly. Rate of increase of resistance is gradually decreasing. At the start, the rate of increase of resistance is higher. So these are the non-linearly, or you can say the rate of increase decreases. Okay, so my answer is right. Here we go. This is the answer. Okay, so we are going to the next question. He says, another student makes changes. This is the E part. Another student makes changes to the circuit shown in the figure 1.1. He uses a variable resistor to vary the current and potential difference instead of resistors wire and the crocodile clip. Complete the circuit diagram on figure 1.1 to show how this is done. Okay. So now they are going to use variable resistor. You see the variable resistor. This is the symbol for the variable resistor. Here we go. You put a line like this. You put a here. And here we go. So this is the symbol for the variable resistors. Okay, so complete the circuit diagram. Let me show you. I've done this here also. So you can see this. So here is the variable resistor. There is the voltmeter. Here is the ammeter. Yeah. So it's good to go. Okay, so let's check the marking schemes. Correct symbols for the variable resistor. Components connected in a correct series circuit. This is the symbol. You can also draw like this. Okay, so we are going to the question number 2. A student determines the acceleration of a free fall by timing the oscillations of a pendulum. The pendulum is shown in the figure 2.1. Here is the retort stand. Here we have the clamp. Here we have a thread. Here we have a bob, and it will be swing. It's a pendulum, okay? The length of the pendulum is up to the center of this, and that is L. On the figure 2.1, measure the length L of the pendulum in centimeters to measure to nearest millimeters. Okay, underline this word. This is measure. Measure means to measure with the instrument. So take a straight edge, or you can call it scale, or some people call it ruler, and measure from your paper how much. If you have a hard copy, how much is this with the help of the scale? Measure. Measure means, okay. So I measured it and I found it to be 3.5 centimeter. 3.5 centimeter is the right answer, sir. This is the length is 3.5. Okay. Then he says this is 3.5 centimeter. Okay. Figure 2.1 is drawn 1/8 actual size. The length L is actual length of the pendulum. Calculate L. Okay. So the L will be each centimeter is equal to 8 centimeter. So it will be 8 multiply 3.5. So it will be 8 multiply 3.5. So you will get the actual length. And I've done this. Map actual, something is 1. In actual, it will be 8. On map, we have 3.5 centimeter. In actual, how much it will be? This is called the proportion method. So 1/8 is equal to 3.5 by x. So x will be equal to 8 multiplied 3.5. That will be 28 centimeter. So the length, the actual length is 28 centimeters. So this will be, the actual will be 28 centimeters. So let's check. 28 centimeter is the right answer. Okay, so we are going to the next part. The question number 2 is B part. And it says, the student gives the bob a small displacement and releases it so that it swings backwards and forwards. Figure 2.1 shows one complete oscillation of the pendulum. So it goes like this, So one complete oscillation has been shown here. Their question is, the student measures the time t for 20 complete oscillations. The time t is shown on the stopwatch in the figure 2.1. So minutes are 00, seconds are 21.21. So write down the time, that is 21.21 second. 21.21 second, 21.21 second. So our answer is 21.21 second. Okay. Question number 2C, and its second part, he says the student measures the time t for 20 oscillations twice more. It's a tricky sentence. These times are shown. Okay. So this is the time is also 21.21. Okay. So he took the reading how many times? Totally 3 times. This sentence is very tricky. He says the student measures the time t for 20 oscillation twice more. One is this, and these are the other two values. So total 3. So their question is, find the average t average for 20 oscillations of the pendulum. You add these 3 and you divide the sum with the 3. Okay, so the t average will be t1 plus t2 plus t3, the whole thing divided by 3. That will be 21.21 plus 21.30 plus 21.28 equals to, divided by 3 equals to, and that will be 21.26. 21.26. That is my answer. 21.26. 21.26 is the right answer, sir. I hope you understand. This sentence is tricky. Mark this. Okay, so question number 2D part, he says the period, capital T, is the time for one complete oscillation of the pendulum. Calculate the capital T. Okay, so whatever is the average time duration, just divide it with the 20, because this is the average time duration for 20 oscillation. So the time for one oscillation will be 21.26 divided by 20. Very simple, and you will get the answer. So it will be t average, small t average divided by 20, and that will be 21.26 divided by 20, and that will be 1.06 second. 1.06 second. So you can see the answer is right, 1.06 second. 1.06 second, the answer will be 1.06 seconds. So that is how you do it. Calculate a value for g, the acceleration for free fall. Use the equation shown. G is equals to 11.1 capital T square. Okay, so it will be 11.1 divided by 1.06 square. Very simple. So 11.1 divided by T square, 11.1 divided by 1.06 whole square, and that will be 9.82 meter per second square. 9.82 meter per second square. 9.82 meter per second square. So our answer is right. They are saying this. Okay. So our answer is between these. 9.82. 9.82 is the answers. Okay. So it will be 9.82 meter per second square. Okay. F part is, he says to find the period capital T of the pendulum. The students first measures the average time for 20 oscillations. Suggest why the student did not choose to measure the average time for 2 oscillations. You see that when you time 2 oscillations with the help of the stopwatch, the time will be very short. It will be short. I mean, the time for one oscillation is 1.06, so it will be 2.12 seconds. So that time is very short. And when you are measuring with the stopwatch, you see the reaction time, the human reaction time will be a large percentage for this time. If you take the human reaction time, so that will be a large percentage of the time for 2 oscillations. So that's why we do not directly measure 2 time period for the 2 oscillations, because then due to the human reaction time, the error created in the reading, that will be very large as compared to the actual reading. So that's why we do not take the time for 2 oscillations. We do not measure directly the time for 2 oscillations. Let me read you my sent. I have tried to write the answer. That is, time for two oscillations is very short. Percentage of reaction time to this time will be large. That's why we are not timing two oscillations directly. So let's check. Reaction time error is significant. Our answer is right. Then second part is 200 oscillation. You see, 200 oscillations will take a very long time. Means it will take longer time. And this is also possible that before the pendulum completes 200 oscillation, the pendulum stops oscillating. Means 200 oscillations. Huh? 1, 2, 3, and before it reaches 200 oscillations, the pendulum might stop swinging. That's why we do not do this. Timing 200 oscillations will be difficult because pendulum will stop swinging before completion of 200 oscillations. Oscillation might stop, might lose count. And that is also possible. You lose count. You are counting up to 200, so it's possible. Okay, so this is our answers, and I hope you understand. That was question number 2. Now we are going to the question number 3. He says, it's a diagram. Okay, he says a student uses a ray box to investigate the refraction of a ray of red light as it passes through a semicircular glass block. He sets up the apparatus on a sheet of paper as shown in the figure 3.1. So here you have a ray box. This is a sheet of paper fixed on a drawing board. And this is a ray box. It's like a torch or a laser light. And here we have a red filter. So it's basically it's a torch from which a beam of light is coming. And here we have a red filter, so only the red light will pass through it. And then it is incident on this semicircular glass block here, and this is the normal. And let's see what they say. The ray is incident at M. The ray is incident at M. And they say the midpoint at the flat surface of the semicircular glass block. Okay, so this is the flat surface of the semicircular glass block. This is the midpoint M. And he said, measure the angle of incidence I of the ray at the point M. Okay, so this is the angle of incidence. Basically, this is called the angle of incidence. Okay, with, mark this word, he says measure. When he used this word, it means that using a protractor, measure how much is the angle between the incident ray and this normal. I have done this and I found it to be 34. So this angle is 34 degrees. 34 degree is the right answer, sir. So we are measuring this angle basically. Okay, this angle. Then they say the angle of refraction at M is 22. On the figure 3.1, draw the refracted ray inside the glass block. Okay. So with this normal, put a protector here, and from here start counting. Wherever the 22 will be, put a dot here, and let's say it will be here somewhere, and then join this line. Okay. So this angle is how much? 22. And I marked it with the help of a protractor. Let me check again. The angle is 22. Okay. So with the help of the protractor, I will mark a dot here. Then with the normal, this angle will be 22. Then I will join this point and that angle, dot, and this will be the line. And here, when it touches the boundary, that is the point N. Label with the letter N the point where the refracted ray leaves the glass block. Okay. We are done with that. We have written N here. Okay, then their question is, C part, the ray emerges from the glass block at N without further deviation. Okay, so it will come out without any deviation. So it will go straight out. Okay, so this is, let me show you, this is the diagram. So from N, the light went out. It emerged into the air without any deviation. Okay, then he says, draw the path. Okay, draw the path of the ray after it leaves the glass. So it will go straight out. Okay. Then he says, describe how the student uses optical pins to mark the path of the ray accurately. Okay, so how you will mark the path of the ray accurately? You will put a pin, because this is light ray going, so you are able to see the light. So here you put a pin and you put a pin here. Okay, and you mark their position, and then you remove it. Then you join both these marks up till you touch the boundary of that semicircular glass block. So this is what I think is the answer. He says place 2 pins into paper at emergent ray. Okay, emergent ray from semicircular glass block. Distance between pins should be more than 5 centimeter. Mark position of the pins on the paper with marker. Join the marks of pin 1 and pin 2 with the boundary of the glass block with help of a ruler, or you can say scale. So let's check. Place pins on the ray and join them, or place the pins more than 5 centimeter apart. I hope you understand why he used the word N. Okay. So we are good. I hope you understand what I mean. Then we have the next question. The next question is question number 4. He says, a student uses a thermometer to measure the temperature of hot water as it cools down in a beaker. Explain why he takes the following steps to ensure that the values are accurate. He makes sure that the thermometer bulb does not touch the side or the base of the beaker. You see, when you put the thermometer in water and you want to note down the temperature of the water, the bulb of the thermometer should be in the middle of the water. If it will touch the base of the beaker, it will start recording the temperature of the base of the beaker instead of the water. That's why it should not touch. Sorry. If bulb of thermometer will touch the base of beaker, it will show temperature of base of beaker instead of temperature of water. That is my answer. Question number 4A part. Side base may be at different temperature. Yes. And the temperature of the base might be different. So it will show that temperature then. Okay, the question is, explain why he takes the following steps to ensure the values are accurate. He stirs the water each time before taking a reading. So you stir the water before taking the reading to make sure that the whole body of the water is at uniform temperature, to make the temperature uniform throughout the body of the liquid. By stirring, he makes sure the temperature of water is uniform throughout the body of water, to ensure that the water is at a uniform temperature. Okay. So question number 4, it's C part. He says, explain why he takes the following steps to ensure that the values are accurate. He takes the temperature reading by viewing the scale on thermometer at an eye level, perpendicular to the scale. You see, wherever you take reading from a scale, your line of sight must be perpendicular to the scale. By doing this, you will be able to avoid the parallax error. If line of sight is perpendicular to the scale, this helps to avoid parallax error. Okay, to avoid parallax error, line of sight error. Okay, so my dear students, we are done with this paper. So, my dear students, today we have completed, in this video, we have solved October-November 2022 Physics 5054 4-2 paper. This was ATP paper, and we have, it was from the zone 2, and we have completed this paper in this video. So, and I have tried my best to explain you the concepts. If you find this video useful for you and you think that can be useful for your friends, for your junior students, for your senior students, for your teacher, Please share the link of this video onto your Facebook, onto your Instagram, and onto your Twitter account. When you do this, this helps me to promote my channel. I think it's a great blessing for me that I can touch the life of so many students by these videos. And I can make the life of those students and their parents and their teachers also little easier by providing them help online. It's a blessing for me and it's a blessing for those students also. Thank you very much for watching this video. Keep watching my videos and also subscribe my channel. Thank you very much. May God bless you.